Hi all, welcome to the next topic of Unit 3, Complements and Fixed Point Representation. Coming to the contents, today we are going to discuss about what are complements, how do you represent a number in a fixed point representation. So coming to complements, in binary arithmetic, complements is nothing but it refers to a method of representing a negative numbers by manipulating the bits of their positive binary equivalent. So as we know that the computer can understand only the binary language, zeros and ones. So whatever in case of binary arithmetic, when you are representing a numbers to perform any arithmetic operations, positive numbers they can be represented as it is. But when it comes to negative numbers, how can you represent a negative number in a computer in the form of binary? So there is a special method that is implemented in the computer in order to represent a negative numbers so that the computer can understand by looking at the bits of the particular number, it can understand that it is a negative number. So complement is a method of representing the negative numbers by manipulating the bits of their positive binary equivalent. First, we'll take the positive binary equivalent of the same positive number, and you're going to manipulate the bits of that particular positive binary equivalent to become a negative number. So that is done with the help of a complements. So there are different types of complements which are implemented in binary arithmetic, like ones complement, twos complement, sevens complement, eights complement, nines complement, and tens complement. But we are not going to discuss about all the different types. We'll stick on with ones complement and twos complement because we are more next topic we are going next half of the third unit we are going to discuss about the binary arithmetic, where we come across different types of flow charts. There we need to implement this ones complement and twos complement operations. With respect to our syllabus, we need to know only about ones and twos complement. So we'll discuss only about what is ones complement and what is twos complement. So the manipulation of bits of their positive binary equivalent using the complement method is done primarily using ones complement. So ones complement is nothing but you're flipping all the bits of your corresponding positive binary equivalent. And in twos complement, you are flipping all the bits of the binary equivalent, positive binary equivalent, and then adding 1 to it. And this complement operations allows is why do we need to perform this complement operations are it helps for performing subtraction operations to be performed using addition within a computer system. So rather than whenever you have a negative number that is involved in the addition operation, that can be done with the help of a complement. Similarly, when you want to subtract two numbers, rather than using subtraction operation, you can do it using addition operation using complements. So that is why you need a complements. So complements are used in a digital computer for simplifying the subtraction and logical manipulations. So first we'll discuss about the first type of a complement, which is ones complement. So this sort of bit flipping, this is nothing but here ones complement we are going to flip the bits of your positive binary equivalent, and this sort of flipping, this ones complement is said to be very simple to implement in terms of the computer hardware because you are just going to flip the bits. So the ones complement of a binary number, it can be obtained by changing each 0 to 1 and each 1 to 0. Or you can implement this ones complement in two ways. One is by flipping the bits of the binary equivalent or positive binary equivalent, or you can subtract each bit from the binary 1. So that is how you can get the ones complement of a binary number. Say for example, this is my binary number 10110000. So if I want to perform a ones complement of this particular binary number, I just need to flip the bits. So this 1 becomes 0. Wherever there is 1, it becomes 0. Wherever there is 0, it becomes 1. So you're just flipping the bits. So that's why we call this as a bit flipping. So so what is the ones complement of this number? It is nothing but 01001111. So this is 01001111. So that is nothing but ones complement. So you can do it in another way also. You have to subtract this particular binary number with all ones. So 11111111 minus this particular binary number. A subtraction operation has to be performed. You know how to perform a binary subtraction, right? So this is one other method of performing a ones complement. But I suggest you to go with the first method, which is very simple to implement. Okay. So this is called ones complement. So if you see the disadvantage of ones complement, we still have two representation for 0. So one in a positive form and other in a negative form. But when it comes to 0, you don't have positive or negative. Both are same. So that is not a exact method to represent 0. So so if you look at a positive way, it becomes 0 0 0 0 0. This is a plus 0. And if you want to represent minus 0 in a computer, it has to be flipped. So all becomes ones. But in case practically 0 is only 1, which is a normal 0. There is no positive or no negative. So that is the main disadvantage of one's complement. Next, we go with the two's complement. So, how do you obtain a two's complement of a given binary number? So, obtaining the two's complement of a given binary number is done by first obtaining the ones complement of the number and then adding 1 to the least significant bit. So that will give you your two's complement. So if you look at this example, so I want to perform a two's complement of this binary number 10110000. So for this binary number, to get a two's complement, I have to first perform the ones complement. So what is ones complement? You have to make ones as zeros and zeros as ones. And then after performing ones complement, you need to add 1 to the least significant bit of the ones complement result. So first I am taking the number here 10110000. So for this is my actual binary number. So for this, I am performing a ones complement. So this is my ones complement. This 1 becomes 0, 0 becomes 1, 0, 0, 1, 1, 1, 1. So this is nothing but ones complement of the actual number. So for this ones complement, I need to add 1 to the least significant bit. So this is my least significant bit. I have to add 1. So 1 plus 1, it becomes 1, 0. 1 plus 1, again it becomes 1, 0. Here 1 plus 1, it becomes 1, 0. And 1 plus 1, again it becomes 1, 0. So 0 plus 1, 1, 0, 1, 0. So this result is nothing but two's complement. So this is how you perform a two's complement of a given binary number. Okay. So next topic is a fixed point representation. So before going into the concept of fixed point representation, I'll just explain you and then we'll see the slides. So normally if you take a computer system, we need to, as a part of a binary arithmetic, we have to represent the integers. So an integer is nothing but, say for example, you are taking 10. 10 is nothing but an integer. So when you represent it in a binary form in a computer, you represent it in the form of zeros and ones, right? So for example, if I am taking 14, I can represent it in as 00001110. So this is the binary representation of 14. But when it comes to negative number. So since this is 14, it means it is a positive. It is just plus 14. So when you are representing a positive number in a in a binary form, you can represent it as usual. How you convert the decimal number into a binary equivalent and represent it. But when it comes to a negative representation, say if you want to give minus 14 to the computer, so how can you give minus 14 as an input to the computer? Can you give like 0000 minus 00001110? Will the computer accept this as an input? No, because the computer cannot understand any language other than zeros and ones. So if you have to represent a negative number to a computer, you cannot represent it like this. So this is not the method of representing your negative numbers. So for that, there are three ways of representing the negative numbers. So they can be represented in three ways. One is using a sign magnitude representation, and second method of representing a negative number is a ones complement representation, and the third method of representing a negative number is two's complement representation. So when a negative number has to be represented in a computer system, it can be represented using any of these three methods. But a positive number can be represented as it is. So say for example, I am taking plus 14 and minus 14. Okay. So when it comes to a sign magnitude representation, you are representing this number in 8-bit representation. So when you are taking an 8-bit representation, say I'm taking it in this form. A representation contains 8 bits. So 1, 2, 3, 4, 5, 6, 7, 8. So this most significant bit in a sign magnitude representation becomes your sign bit. Okay, this is your sign bit. And the remaining 7 bits, we call them as magnitude. So that is the reason we call it as a sign magnitude representation. So when you have to represent the number plus 14 in a sign magnitude form, it will be represented as 0. The sign bit will be 0. So remember, whenever you are representing a positive number, the sign bit for a positive number will be 0. So 0 represents, if your sign bit is 0, it represents it is a positive number. If the sign bit represents 1, it indicates it is a negative number. So if I want to represent the number plus 14, my sign bit will be 0, whereas my magnitude will be 0, 0, 0, 1, 1, 1, 0. So this is my binary equivalent of plus 14. So this is how you represent a positive number in a sign magnitude form. When it comes to a negative number, your sign bit becomes 1, whereas your magnitude is nothing but the same binary equivalent of your positive number. So the sign bit only will change. The remaining binary equivalent of the positive number will be the same in terms of representing a negative number in a sign magnitude form. So the minus 4 binary sign magnitude representation will be 1, 0, 0, 0, 1, 1, 1, 0. So only the sign bit is changing, but the magnitude remains the same. So this is about sign magnitude representation. Next, coming to a ones complement representation. So in terms of either sign magnitude representation or a ones complement representation or two's complement representation, the positive number will be the same. The representation of a positive number plus 14 will be the same. Only the representation of negative numbers, how they are represented in these forms will differ. So for plus 14, the ones complement representation will also be the sign bit 0 and the magnitude part 0, 0, 0, 1, 1, 1, 0. This is the ones complement representation of a positive number plus 14. But when it comes to ones complement representation of a negative number 1 minus 14, what you have to do is you have to perform a ones complement of entire positive number including its sign bit. So you need to toggle all the bits of the binary equivalent of plus 14. So it becomes 1, 1, 1, 1, 0, 0, 0, 1. So this is the ones complement representation of minus 14. So next, coming to a two's complement representation. So when it comes to two's complement representation, the plus 14 will be the same. So it is represented as 0, 0, 0, 0, 1, 1, 1, 0. When it comes to minus 14, you have to perform plus 14, one's complement, and then add 1 to it. So which means it becomes 1 1 1 1 0 0 0 1. So for this you need to add plus 1 to the least significant bit. So what it will become? So here you have to add. So 1 plus 1, it becomes 1 0. Here it becomes 0 plus 1 1, 0 0 1 1 1, and sign bit becomes 1. So this is the 2's complement representation of minus 14. So when it comes to negative numbers, when you are representing a negative numbers in a binary form in a computer, there are different ways of representation called sign magnitude representation, one's complement representation, and two's complement representation. um, the best way to represent a negative number is a two's complement representation, because there are some drawbacks with respect to a sign magnitude representation and one's complement representation. In terms of sign magnitude representation, when you have to represent 0, the same thing, it will be a problem where your sign bit will change. You have to, for negative 0, you have to give the sign bit as minus 1. So as we know, 0 is 1 and the same. So you cannot change the sign bit or anything. So here the best way to represent a negative number is a two's complement representation. So positive integers and 0 can be represented by unsigned numbers. So when it comes to numbers, here actually there are two types of numbers called signed numbers and unsigned numbers. When it comes to numbers, number system, they are classified into two types. So it is classified into two types. One is unsigned numbers and other is signed numbers. So what are signed numbers and what are unsigned numbers is, signed numbers means you can represent only positive numbers. You cannot represent a number in a negative form using unsigned representation. But in case of a negative numbers, they can be represented in a signed representation. So, in case of a signed representation, when you are representing a negative number, they can be represented in these three forms: sign magnitude, one's complement, and two's complement. But in case of unsigned representation, you can give only the binary equivalent of a particular positive number by having a sign bit as 0. But to represent a negative number, that is done only using a sign representation, which can be done using a sign magnitude representation, one's complement representation, or two's complement representation. Positive integers and 0 can be represented by unsigned numbers. Negative numbers must be represented by signed numbers, since plus and minus are not available, only ones and zeros. So signed numbers have a MSB, most significant bit, as 0 for positive and 1 for negative. So in case of a positive number, the most significant bit, the sign bit will be represented as 0, and for a negative number, the sign bit is represented as 1. So there are two ways of representing the binary point position in a register, that is a fixed point representation and floating point representation. We'll see that. So so here if you see, when an integer is positive, the MSB bit will be 1 and the remaining bits represents your magnitude. When an integer is negative, the MSB bit will be 1, and but the rest of the number can be represented in three ways. You can represent it using a sign magnitude representation, signed one's complement representation, or signed two's complement representation. So this is how we represent the numbers in all the three forms. So the fixed point representation is nothing but the sign magnitude representation. So 8-bit register, 14 is my number. The same example, whatever is explained, it is done. 8-bit how you represent a minus 14 in a sign magnitude form, sign 1's complement form, and sign 2's complement form. So next we'll take a real number. Since till now we have seen how to represent an integer number, whether it is a positive or a negative. But when it comes to a real numbers, how do you represent using a fixed point method? So here, say I am having a number 41.6875. How this can be implemented using a fixed point representation. Fixed point representation is nothing but, especially in case of a real numbers. Real numbers means where we have a decimal point in the particular number. So if you take 10, 15, those are just integers. But in case of a real numbers, you have a point like this within the number. So when the in this number has to be represented in a fixed point method. How do you do is, we call this as an integer part and this as a fractional part. First we take the integer part of the number and divide it by 2 and convert it into a equivalent binary representation. So 41, we know how to convert a decimal number into a binary form. So so here we are using that method to convert a decimal 41 into a binary form. Similarly, we have also seen how to convert a fractional part into a binary form. So 0.6875 has to be converted into a binary form. So this is how, into 2 we multiply it with 2. So until we get the most significant bit of the fractional part as 0, we repeat the process. So since here we got most significant bit of the fractional part as 0, we stop here. So this this 1101 is nothing, your binary equivalent of your fractional part of your number. So together we combine, it becomes, so I am representing this number in a 8-bit format. So 8 bits for a integer part and 8 bits for a fractional part. So since I have only 6 bits here, I am adding zeros here. So it becomes 00101001. This integer part, binary equivalent. Similarly, here I have only 4 binary equivalent. I am having only 4 digits. I am adding zeros in the LSB side. So I am making it 10110000. So together it becomes 101001.1011. Normally we can add these two and write it here, but if you want to represent in a 8-bit format, integer part separately and fractional part, you can add zeros like this. If for integer part you have to add it on the MSB this side, MSB side, whereas for fractional part you have to add zeros on the LSB side. So this is how you convert a real number into a fixed point method, fixed point representation method. So this is one more example for converting a signed fixed point representation. You are going to take a signed number which is a negative value, a negative real number, and how you can represent this in a 8-bit binary format. And if you see the question here, represents minus 7.5 using 8-bit binary representation with 4 digits integer and 4 fractional bits. So if I have to convert this number, first I have to convert it into a binary form. Forget about the minus. We'll look at it later. First, we'll take the number 7.5. We take integer part separately and fractional part separately and convert them into a binary form. So, the binary form is 111.1. So, this is your binary form. So, 7 is 111 and for a fractional part, it is 0.1. So, I am combining it and making it 111.1. So, they gave it in the question that represent it with 4 integer digits and 4 fractional bits. So, my integer part should contain 4 bits, fractional part should contain 4 bits. So I replaced it with, I added zeros to the MSB for the integer. I made it 4 bits. So it becomes 0111. Similarly, at the fractional part, I added zeros at the LSB side. So that it becomes 4 bits. So 100. So that I have a 4 integer and 4 fractional digits. So this is my binary equivalent of plus 7.5. Now I have to consider minus. So in that case, to become a positive number into convert to represent a negative number, what I have to do, I have to convert. The best method is converting it into a 2's complement form. I am representing it in 2's complement form. So that is nothing but 1's complement plus 1. So I am taking this number and performing a 1's complement. So it becomes 1000.0111. So this is my 1's complement of the given number. So I'm adding 1 to it. So it becomes 1000.1000. So this is a 2's complement. So this real number, the signed real number, can be converted into a fixed point representation using this method. So the position of, if you look at this number, the position of the binary point is fixed. You cannot move it either to the MSB side or you cannot move it to the LSB side. The position of this particular decimal point is fixed in case of a fixed point representation. But in case of there is other method of representing it, that is a floating point representation. So in that case, the position of your binary point will, it can move either to this side or this side. It floats. So that is the reason we call it as a floating point representation. So, but in case of the reason why we call it as a fixed point representation. So this is specially applicable to real numbers. When we have a decimal point present in the particular number, then the point is going to be fixed. So with that is the reason we call it as a fixed point representation. So, so this is about today's lecture. We'll see it in the next class. Thank you.